teach down the hall, I actually teach language arts. I teach computer literacy, which is like technology stuff. I teach that too. And then one of the fun things I get to do as part of my job is I am a STEAM coach. And STEAM stands for science, technology, engineering, art, and math. So I help out with the TAG program a little bit, with the robots. And then I get to come in and do fun things with you guys, which is really seriously the highlight of my time. So yesterday I was in a fourth grade classroom and we built turkey shelters. And then I taught the kindergartners how to do the bee robots. Have you seen those where you program the bee robots? Yeah. Oh, maybe I should bring those in here. But today, we're going to be working on the engineering cycle. And the engineering cycle has 5 steps. I'm going to ask you a problem. I'm going to give you a challenge, really. Then we're going to brainstorm a solution. Then you're going to make a plan. You're going to create something. Then after you kind of create your model, you're going to look at what everybody else does, kind of get some ideas and see if you can improve your model. Do you want to know what you're going to build today?
I have.
That wasn't very enthusiastic. Do you want to know what you're going to build today?
Yes. Yeah.
Today, the Mayflower is taking a voyage to New England. The ship needs to hold as many pilgrims as possible.
Shit.
Construct a Mayflower ship that will hold pilgrims while still staying afloat. You'll have 12 minutes to design your boat. See that little thing back there? That little tub of water?
Yeah.
Okay, that's our ocean. That's what we're going to float our boats in.
So
Okay?
wouldn't it be like this big then?
What does it mean if something's buoyant?
No.
What does buoyancy mean?
Big.
It floats. So you need to make sure, I'm going to tell you your materials in a little bit, but you need to think about buoyancy as you're building your boats. You want it to float, okay? And you also need to think about stability. What is stability? What does it mean, stability? Yes.
Sturdiness?
Sturdy. And with a boat, we have to make sure it doesn't do what? Flip. So we have to make sure that it's stable, that it's going to stay up and down. I don't know if that's the right term, but we want to make sure that it stays afloat, okay? So we want to make sure that it doesn't go this way or that way, okay? All right, you ready to know what your materials are?
Yeah.
All right, your materials. Oh, first, sorry, we have to talk about what you already know about boats. What are some parts of a boat? Think Mayflower-ish, not like ski boat that some of you might know. Joe?
The sail.
Sails, okay, what else? What else, Tegan?
The hole.
The hull, is that the front or the back? Okay, bottom, okay. Those are the 2 main parts. So I want you to think about that as you're designing with your teams in just a minute, okay? All right, now let's talk about materials. You will get 2 sheets of aluminum foil. 2 sheets of aluminum foil. You will get 3 styrofoam objects. You can decide whether you want it to be cups or plates or a combination of both, okay? If you take, say, 3 styrofoam plates and you decide you'd rather have a cup, I will accept trade-ins for materials, okay? You can have unlimited amount of Scotch tape. So every group will get a tape dispenser of Scotch tape. You will get only 2 feet of masking tape, okay? 2 feet of masking tape. The pennies are going to be our pilgrims, so you kind of need to keep that in mind as you're building your boat, that we're going to put it in the water and see how many pennies your boat will hold before it sinks, okay? And then I've got the water tub back there. Questions about what we're going to do? You have 12 minutes in your groups to build your boats. Then I give you a 2-minute gallery walk time. How many of you have been to an art museum before? Okay? And you go around, you kind of look at the pictures, right? Okay, well, we're going to look at each other's boats. Do we touch things at the art gallery? No, unless you want to get kicked out. So don't touch anybody else's boat. You're just looking. Engineers get ideas from other people, and then they take them back to their own individual design and apply that sometimes. Okay? Did we create one computer and just stick with one computer? No, we constantly are improving it, right? We took that base model and we're constantly improving it. That's what engineers do. Any questions? All right. Mrs. Hill, you want to put them in their groups of 3?